this video, we'll look at some examples from Precalculus Algebra for graphing. There are a few examples in our learning guide that give some information about graphing with a graphing calculator. We'll skip those examples, but we'll look at a quick review of how to graph on an XY axis. To open our section, we're given this teaser for a problem later in the section, not in this video, but in the textbook, and it's Let It Snow. The arrival of snow can range from light flurries to a full blizzard. Snow can be welcome as a beautiful backdrop to outdoor activities, or it can be a nuisance. We'll look at how graphs can be used to explain the mathematical concepts of everyday situations, such as snow. Specifically, in this application exercise, you'll match stories of varying snowfalls to the graphs that explain them. And here's our examples, and what you should be doing is hopefully I already have the learning guide pages printed, and you'll see on the left-hand side of your page there's a problem worked out, and then on the right-hand side of the page, that's where you should be filling in notes from this activity, from this video. So to just get started, we're looking at graphing some points, and remember that the point goes X, Y, they're in alphabetical order, and remember that the x-axis goes left to right, it's a horizontal line, and the y-axis goes up and down, it is a vertical line. Here we have a nice graph paper axis so that we can find these points a little more precisely. And what I'll do is I'll graph first the 1, 4, so that means x is 1 and y is 4, so I go right 1 and up 4, and that is point A. Point B, x is negative 2, y is positive 3, so point B would be this blue point. Point C, x is negative 3, and y is negative 5, so I'd be left 3, down 5, and that'd give us point C. And then finally point D, x is negative 4 and y is 0. We're on the x-axis, so there are the 4 points. There's a quick review on plotting points on the xy axis. Again, the first point is always left and right. The second point is up and down. True or false, if a point is on the y-axis, its x-coordinate must be 0. So if we look at all of the points that are on the y-axis, we can see that that is in fact true, that x is 0. So another way of saying plot a point where x is 0, another way of saying that is plot a point that's on the y-axis. We could sometimes call that point on the y-axis a y-intercept. Next, we've got an example that asks us to graph y equals x squared minus 2. You might recall how to graph that as a parabola that just starts 2 units down, a vertical shift of negative 2 or 2 down. But what you can always do to graph equation is you can always plot some points. So we're given which x's to find. I'm going to make a xy chart to find those points. So what I'm going to do is I'm going to replace the x with a negative 3. Make sure you recognize that that whole negative 3 is squared. It's not the opposite of 3 times 3. It's a negative 3 times a negative 3. So negative 3 times negative 3 is positive 9. 9 minus 2 is 7. So it looks like we have the point when x is negative 3, y is 7. And then when x is negative 2 squared, so that's negative 2 times negative 2 is 4. 4 minus 2 is 2. Negative 1 squared is 1. 1 minus 2 is negative 1. 0 minus 2 is negative 2. 1 squared minus 2 is, that's 1 minus 2. Here we get a repeat, negative 1, right? And then 2 squared is 4. 4 minus 2, there's our second repeat. Negative 2 or 2 gives us the same y value. And then 3 squared minus 2 will be the same as negative 3 squared minus 2, or 7. When I plot these points on the xy chart, the xy axis, I would get negative 3, positive 7, negative 2, positive 2, negative 1, negative 1, 0, negative 2, and so on. You can see how we get some symmetry across the y-axis, and connecting those dots gives us this parabola that takes this shape. Now, just plotting the points that we had, we wouldn't have arrows at the end, but since the x's continue in both negative and positive directions, we could put arrows at the top to show that as I pick more x's, I'll get more y's to the right or the left. Let's look at number 3. For number 3, we've got another graphing, but this one is an absolute value. You might recall that the shape is going to come out like a V. You can see I've drafted in a chart for this. When x is negative 3, we have 2 times the absolute value of negative 3. The absolute value means to make a negative number positive. So 2 times 3 would give us 6. 2 times positive 2 is 4. 2 times positive 1 is 2. The absolute value of 0 is 0, so 2 times 0 is 0. 2 times 1 and 2 times 2. So if you recall, the absolute value of a number is its distance from 0, so it'll never be a negative number. The absolute value of a negative number is positive. The absolute value of a positive number is positive. And then the absolute value of 0 is always just 0, which is neither positive nor is it negative. So we could graph these points negative 3, 6, negative 2, 4, negative 1, 2, 0, 0, and so on across the axis here because we get repeats, symmetry. So see how that y repeats. When x is positive 2, y is 4. And we could continue that to get that V shape for the absolute value. Good review of graphing with an XY chart. Number 3, what's the meaning of a viewing window that's given here? I'm not going to worry about this problem. You can put an X on that in your learning guide because we won't be using a graphing calculator. Let's look at number 4. Identify the X and Y intercepts. Now remember that the x-axis is the axis that goes left and right, and here's our x-intercept. We cross the x-axis when x is equal to 2. So the x-intercept is x equals 2. The y-intercept is when when we cross the y-axis, and it looks like that's a negative 1, 2, 3, 4. So y equals negative 4. Those are the intercepts. For number 4b, the y-intercept, notice that there is none. I'm going to say DNE for does not exist. The y-intercept doesn't exist because that sideways parabola doesn't cross the y-axis. But I do see an x-intercept. Looks like we cross the x-axis when x equals negative 1. So we have an x-intercept of x equals negative 1. Number 5, our last problem, 3 parts. We've got a graph given, and we're going to use that graph to answer 3 questions. So let's make sure we understand the graph. The graph shows a percentage of high school seniors who used alcohol or marijuana in the United States. It doesn't give it gives us the years, and we can see how they increase or decrease. So I can read this, and it looks like the alcohol use is decreasing from 1990 to 2019, and marijuana use increased a little, and then it tapered off and has stayed somewhat constant. The data for seniors who use marijuana can be modeled by M equals 1/10 times N plus 43, where M is the percentage of seniors who use marijuana N years after 1990. So use this formula to determine the percentage of seniors who used marijuana in 2010. So the number of seniors who used marijuana is 1/10 of N plus 43. And in 2010, that is going to be 20 years after 1990, because 2010 minus 1990 gives us 20 years. So when N is 20, I can find that M is 1/10 of 20 plus 43. Now, feel free to use a calculator if you need, but hopefully maybe you wouldn't need to for this one, because we're just doing 1 times 20 and then taking back 1 decimal place, so that's going to be 2. But we'd get M equals 45, so we can say, since it's said to determine the percentage of seniors, we can say therefore 45% of the seniors used marijuana in 2010 on average. I hope that doesn't encourage you to try marijuana if you haven't yet. But let's keep going. 5B. Use the appropriate line graph to determine the percentage of seniors who used marijuana in 2010. Well, we've found it using the formula. Let's see if we can find it here on the chart. So on the chart, I'm going to switch over to a highlighter here. And what we're going to look for is when N equals 20, so the year was 2010, find where the line for marijuana crosses. And do you see it here? This point right there. Looks like that's right at between 40 and 50%, so we can see that it's 45% from that graph also. So you see we could use the equation or the graph to find that value. Does a formula underestimate or overestimate the percentage? When I look at it closely, I'd have to really make it bigger, and on your paper you could probably see that a little bit bigger. My picture is so small here on the screen, it's hard for me to really see it, but I can barely, if I have to guess, it looks like that point on the graph is slightly lower. The graph is slightly lower, so it looks like the formula overestimates. Just slightly. The formula slightly overestimates from the graph. And the reason why we're not getting a precise value is that this is not a linear graph. It doesn't give us a nice, concise, straight line. The values shift up and down, up and down. So it's not always going to, using the formula is not always going to give us a precise value, but it gives us a nice estimate either way. Well, I hope that this short video has been helpful to you in understanding a little bit more about graphing. If you do have questions, I hope you'll reach out to me and let me assist you with that. We can answer questions about the videos in class or in email in between or in the office in between. But thanks for making time for the video, and let me know how I can help you understand any of the examples a little bit better if you had any questions.